Next thing you write is this: when an electromagnetic wave passes through any point in the space, the electric field E vector and B vector oscillate mutually. Vectors oscillate in mutually perpendicular planes, perpendicular to the direction of propagation of wave.
I got disconnected. What do we have to write again after the phase difference?
This line, when EM waves. Can you see what I'm annotating on the screen?
Yeah, now I can.
Yeah, okay. Okay, these three lines. Okay. After this, make this diagram. After this, write the energy of EMW. Don't write full electromagnetic, write EMW in place of electromagnetic waves. The energy of EMW is equal to KE of the charges oscillating between the two spheres. Fine. The energy of the EMW is equal to the KE of the charge oscillating between the two spheres. Okay. Next, I'll explain you how do you see. Right, this is whenever there is a bracket. Okay, bracket में omega t minus kx है. Okay, right, in the bracket, if it is omega t minus kx, the wave is going in plus x. So in which direction it is going is given by omega t minus kx, so x plus x. Okay, write this, make this box actually. Okay, make this box and then write, yeah, make this box, right? Write this omega t minus kx, right? Wave is going in, और यहाँ पे लिखना, पूरा मैं नहीं लिख रहा हूँ, लिखना wave is going in plus x. ठीक है, plus x, wave is going in plus x. then लिख दो wave, ऊपर लिख लो wave propagation in plus x. Fine, sin और cos कुछ भी हो सकता है, doesn't matter, sin or cos. Okay, next you write if it is omega t plus kx, then it is the wave propagation is minus x. Fine. Arushi?
Yes.
If it is omega t minus ky, what is the wave propagation direction?
Plus y.
Plus y. You have to write one more thing, that if both the either same sign, if they're same sign, okay, omega t and kx are of the same sign, then it goes in the negative direction. If omega t and kx are in the opposite sign, then it is plus x. So, Arushi, what is इसका propagation direction क्या है?
Minus y.
हाँ?
Minus y.
Minus y, ये x लिखा है.
Oh, sorry, minus x.
माइनस एक्स क्यों? क्योंकि दोनों सेम साइन के हैं. ओके. What about this one, Saisham? What is the propagation direction of this?
Plus x, right? Plus y.
Plus
Plus y.
this, plus this
Z.
symbol.
Plus z.
Plus z. ठीक है? ठीक है, fine everyone. So this orange box you have written, everyone. The next make green box. Green box में लिखो. The wave propagation is in the direction of E vector cross B vector. Okay, E vector cross B vector. One more thing you write. The wave speed, which is c speed. Okay, c is E naught by B naught. Okay, so this is all you need. Using this, you can always write the B given E and E given B. Okay, let's see how do you write E and how do you write B. Okay, ये 3 points on orange box. Second thing is this wave is E cross B, and the third is wave speed, which is c. Speed लिखना तो बोलो. Okay, speed is c is the speed of light, right?
Yes, sir.
1 second. Okay, give me 1 minute. Yeah. Now write this. Ey is equal to E naught sine omega t minus kx. Okay, Ey is equal to E naught sine omega t minus kx. यहाँ note down करना ये E naught और B naught है. These are magnitudes. Okay, of the E naught and B. It is not E just E and B. It is E naught and B naught magnitudes. Okay, now see. Everyone has noted till here. Now next is see, write this and write what is the propagation direction, Ansh?
No, it's plus k. Oh, plus x, sorry.
Plus x, right? Wave propagation. The propagation of E is given by this subscript. So what is, in which direction is E going in plus y?
Yeah.
Plus y. After this, you will make x, y, z, or yeah, x, y, z, x like this, y like this, and no, don't write x, y, z, write I, j, k. Okay, I, j, k, I, j, and k like this circle. Okay, everyone make this circle and then make an arrow like this. So write I cross j is k, j cross k is I, and k cross I is j. Write this. I cross j is k, j cross k is I, k cross I is j. If you go reverse, write also j cross I. If you go in the reverse direction, okay, anti-clockwise, then you are supposed to put a minus sign. For example, write j cross I is minus k. J cross I is minus k. Fine. Ansh, what is k cross I? जोर से बोलो.
J.
J. What is I cross k?
Minus j.
J cross k?
J cross j is I.
K cross j?
Minus I.
J cross j?
0.
Yes. Good. ठीक है. Now, the wave is in the direction of E cross B, right? So E is in which direction? Ansh.
I asking me.
Yeah, I'm asking you. E is in which direction?
Y.
y is what? Which one? Which axis?
J.
J. तो E इसमें है. Wave propagation किसमें है?
X, which is I.
I. तो wave propagation इसमें है. That means magnetic field किसमें था?
K, which is Z.
Z.
No.
That means when you write B, you will write BZ, right? When you write B, write BZ,
Yeah.
okay?
Okay.
And then you will write B naught. So when write BZ, B naught, and then you have to copy this. This trigonometry you have to as such copy. So B naught sine omega t minus kx, right? Sine of omega t minus kx. Understood, everyone?
This is like find what?
What?
Like, why do we use this equation? Like BZ is equal to B naught sine whatever. Why do we use this? Like, what is the utility of it?
Oh, what is the use of this? See,
Yeah.
the question will be asked. See, very simple. The concept is the electric field has two components. Sorry, the electromagnetic wave has two components. It is made up of an oscillating electric field and an oscillating magnetic field. Good that you asked. Oscillating electric field and oscillating magnetic field. One electric field is this red vectors which are oscillating in the, if you see, they're oscillating in which plane?
Why plane?
XY plane. Yeah, XY plane. Everyone can see they're oscillating in XY plane.
Yes, sir.
Right? And the E vectors are going in Y direction. Yes, E vectors are going in Y direction.
Yes, sir.
So if you want to write E as a function, you'll write EY is equal to E naught something, right?
Yeah.
Similarly, see the B vector is in the Z and which plane?
ZX.
ZX plane, right? Everyone?
Yes.
Yes,
And
sir.
B is oscillating in Z direction.
Yeah.
Coming out. So E is in Y direction, which is J. E is in Y direction, which is J. B is in Z direction, which is K. So what is J cross K? What is J cross K? I, J, K. What is J cross K?
Oh, it's I.
I. That means the wave is going in I plus I. Yes, wave is going this direction of propagation. Okay. Now given, suppose I can, so in this question, I gave you, when I was discussing, I gave you direction of electric field, direction of magnetic field, and then you crossed them, E cross B, and then you found out, by the way, you can cross it like this also, wo jo haath wala hai, cross, E cross B, cross product, right? So E cross B cross product, you will see the thumb goes in plus X. And so I gave you E, I gave you B, and asked you direction of propagation. So these are three things. I gave you two things, and I asked you the third thing, right? I can give any two things. I can give you direction of propagation and E, and then ask you where is B, right? So you'll have to check E cross what is direction of propagation. So that's what we were doing. If E is like this, okay, you have to write B ka vector. So first you have to decide the direction, which we just did, BZ, right? And then you have to determine the amplitude, which is given by amplitude. You can always find by E naught by B naught is C, right? E naught by B naught is C. So E naught de rakha hai yahan pe. You divide it by C, you will get B naught. So B naught, and then just sign wala to copy karna hai. Okay, fine everyone?
Yes, sir.
I will do one more example of the same thing. Say, it doesn't have 1 second. See this. So you Ansh, you tell me, this is the wave B ka thing, right?
Yeah.
It is omega x plus kt. In which direction it is going? The wave is going. Write this, everyone. Okay, write this, everyone.
My direction.
Y direction. In which direction the wave is going? Determined by this.
Oh, okay. So
remember the orange box?
yeah. This should be in minus X actually.
Minus X. Wave is going in minus X. Minus X means in
It's
IJK it is?
In IJK it's minus I.
Minus I, yes. Okay. Minus I. B is in which direction?
Y, which is J.
B is in J, right? So if I, J, K, right? And E cross B is wave, E cross B, right? So this is B, right? And this is wave, right?
Yeah.
Sorry, wave is actually minus I. And E cross B gives you, so E must be in this, right?
Yeah.
Plus K or minus K, you have to decide. You can do it. E cross B should be, do you do plus K or minus K?
It should be
Your
plus
voice
K,
is
right?
big. Plus K, right? Because
So I'm saying yeah.
you said plus K, right?
Yeah, I said plus K.
Plus K cross J will give you minus I, right? So
Yeah.
that's why you should write E as plus K, no? Plus K to EZ, right?
Yeah.
EZ is equal to, then we will go with E naught. E naught लिखना है, and then वो जो साइन वाला है वो ऐसे ही कॉपी कर देना है, राइट? ऐसे ही पूरा कॉपी
Yeah.
कर दो, ठीक है? और E naught की वैल्यू क्या होगी? E naught की वैल्यू क्या होगी? B naught की वैल्यू कितनी है? B naught की वैल्यू, B naught ये है बेटा, ये एम्पलीट्यूड,
It's like 200 to minus.
ये B naught है, तो E naught और B naught का रिलेशन क्या है?
E naught by B naught is equal to C.
हाँ, तो कर निकालो. C is 3 पता है ना क्या था? C what is 6?
60?
3 into 10.
हाँ, 3 into 10 power 8, right? तो multiply this
Yes.
into 3 into 10 power 8. तो कितना आएगा?
6 into 10. I mean 6 into
60
yeah.
ना?
60.
इसलिए देखो ये आंसर समझो, इस आंसर को समझो क्या लिखा है. Understood?
Yes, so
कॉपी कर लो उसको. Write 2 more things. First thing is K is equal to 2 pi by lambda. K is equal to 2 pi by lambda. माइनस भी इसमें K कितना है?
So यहाँ पे एक सेकंड, kx, right? So it's 0.5 into 10 to the power 3. So
वहाँ से
is
lambda
first question में, right?
हाँ फर्स्ट, हाँ इसी
Yeah,
में
yeah.
K की वैल्यू ये है, ठीक है? तो लैम्डा निकल आएगा वहाँ से.
हाँ सर, आ
और
जाएगा.
दूसरा फॉर्मूला ये होता है ओमेगा इज 2 पाई एफ, 2 पाई एफ, ठीक है? 2 पाई एफ, फाइन. एक फॉर्मूला
Yes.
और होता है, एक फॉर्मूला और होता है कि वेव स्पीड जो होती है, वेव स्पीड वो होती है ओमेगा बाई के. ओमेगा बाई के क्या होती है? ओमेगा बाई के. अच्छा, इसमें ओमेगा की वैल्यू और ओमेगा बाई के करना, देखो कितना आ रहा है. ओमेगा बाई के करो इसमें, बताओ बताओ कितना आ रहा है. मानसी ओमेगा की वैल्यू कितनी है?
So 1 second. So I'm supposed to put the value and tell you the final
ओमेगा की
answer.
वैल्यू कितनी है, बस इतना पूछ रहा हूँ.
0.5 into 10 to the power 3.
ओमेगा, ओमेगा
2 pi
के नहीं
f.
पूछा, के एक्स प्लस ओमेगा टी है
Okay,
ना.
so
इट इज के एक्स प्लस ओमेगा टी.
yes, so sorry, so 1.5 into 10 to the power 11. Sorry, sir.
के का वैल्यू कितना है?
K is 0.5 into 10
डिवाइड
to the
करोगे क्या
power.
आएगा? ओमेगा बाई के.
C, 3 into 10 to the power 8.
वो तो ओमेगा, अगर इलेक्ट्रोमैग्नेटिक वेव दे रखी है तो उसकी करने की जरूरत नहीं है ओमेगा बाई के, वो सी ही आएगा. ओके, देयर इज नो नीड टू डू इट, बट इफ यू जस्ट डू इट, ट्राई टू अंडरस्टैंड, मतलब तो ओमेगा बाई के सी. Also, you should also write this is when it is traveling in vacuum. Okay, if it travels in a refractive index of medium mu, then you know v is c by mu, right? Glass में जाता है तो speed होती है c by 1.5, right? Has a ये समझ में आ गया सबको? ठीक है? Write this on that also. अच्छा, इसके बाद so Aditi, only the first part is deleted, right?
Oh yes.
Oh, that means you have all this, right? अब इसके बाद ये तो पढ़ लिया, अब ये लिखो. हाँ, ये important fact. The velocity of electromagnetic waves in free space is this. ठीक है? In free space, in vacuum, it is this. You already know the इसका values लिख लो. Mu is 4 pi into this, 4 pi into this, and epsilon naught is this. इन दोनों का वैल्यू डालोगे इसमें epsilon naught mu naught और कैलकुलेट करोगे तो ये इतना आ जाएगा c. ठीक है, ये भी लिखो, फटाफट लिखो उसको. C is 1 by, yeah, everyone has written this.
Yes, sir. So, and this formula is only when the waves are in vacuum, right? Like,
Yes, it is in vacuum. Yeah, when it is in right, it is in some medium, then the formula becomes this without the subscript, of course. Okay, because it is not vacuum. So epsilon naught, mu naught are subscript specifically or vacuum. If it is some medium, then you just delete the knots, and also don't write c because then the speed is not 3 into 10 power 8. So you just write v. Okay, so write this formula. V is 1 by mu root 1 by mu epsilon naught, and then yeah, write these two things also. Epsilon mu ये जो mu है इसमें ये है actually mu naught into mu r, vacuum into relative. Okay, and the epsilon which is there in the formula, in this formula, okay, epsilon which is there in the formula, it is epsilon naught into epsilon r. Okay, it is also in electrostatics that ratio has a special name called dielectric constant. In or relative permittivity, in magnetism it is relative permeability. जो इसका यूज ऐसे होता है कि suppose there is a medium which has relative permeability 3 times, that means उसका mu कितना होगा 3 into vacuum का. vacuum का permeability कितना है इतना, तो उसके में डालोगे तुम 3 into this number. ओके, अगर किसी मीडियम का relative permeability 3 है तो, और किसी मीडियम का अगर relative permittivity 4 है तो you will put, or they can also call it relative permittivity, they can also call it dielectric constant. So if the dielectric constant of a material is 4, you will put its epsilon value as 4 into this value, 4 into this value. Okay, fine. And you can also see that you don't need to actually put those values in those numbers and then put mu and epsilon on. You can just take out those factors. If you take out those factors, अगर suppose एक question में medium का relative permeability 3 दिया है, ठीक है, और relative permittivity 4 बोला है, और फिर पूछा है कि what is the speed of light in that medium, तो तुम नीचे यहाँ पे देखो स्क्वायर रूट में, नीचे स्क्वायर रूट में क्या आएगा, नीचे एक 3 आएगा, फिर एक 4 आएगा, राइट, और फिर तो सब कुछ वही रहे, और उसके अलावा तो एवरीथिंग इज सेम. So you are actually putting out a factor of 1 by root 12, right? So your answer will be C divided by root 12. Understood? C divided by root 12. Fine.
Yes, sir.
Yes.
Yes. I have a question for Aditi. Aditi, I have a medium in which the relative permeability and relative permittivity both are 2. Okay.
Yes, sir.
What is the speed of light in that medium?
1.5 into 10 to the power 8.
Very good. C by 2.
Yeah.
Yes. One more question. I have a medium in which relative permittivity is 2 and relative permittivity is half. What is the speed of light in that medium?
The same.
Yes, very good. Everyone. Has everyone understood what she has replied and why she has replied? What?
I don't understand the second question.
Second question, I said relative permeability is 2 and relative permittivity is half, right?
Yeah.
So if you see the factor में नीचे root में पहले 2 आएगा और एक half आएगा, right?
Mm-hmm.
So this will cut off.
Oh, right. Okay.
So you are just dividing by root 1, which is just like dividing by 1. Okay, so your speed will remain same, which is 3 into 10 power 8 meter per second. Okay. Next one, write one more thing that the are into K. Write this. There is nothing to explain here. I mean, this is easy. You what we are doing is see. तुमने यहाँ से suppose glass में तुमने डाला और V निकाला उसका, ठीक है? Glass का म्यू और एप्सिलॉन ग्लास डाल के V निकाला, ठीक है? और लाइट का म्यू नॉट एप्सिलॉन डाल के C निकाला. Then if you do C by this V, then what is this ratio? C by V. ये ratio. ध्यान से देखना, ये C speed of light in vacuum divided by speed of light in glass. ये ratio को N बोलते हैं ना, refractive index, right? So do you understand, if you divide these two numbers, on the right hand side you will have a division of numerator में you will have mu naught epsilon naught and denominator में you have under root of, yeah, if you divide, no, yeah, correct, mu naught epsilon naught, right? Yes, understood everyone?
Yes, sir.
वही लिखा है यहाँ पे, ये हाँ ये वही लिखा हुआ है. So n is, so you see this mu by mu r mu naught क्या होता है? Mu by mu naught is just mu r, right? So it is mu r into epsilon r का square root. That's this formula. N is C by V is square root of epsilon naught mu r epsilon r, relative, right? Understood? Okay. Cool everyone. ठीक है. Okay. Write this. I hope you have written this. All this you have written this in your notebook. This and this and this. Write this quickly. अभी बाद में होगा, बाद में होगा. हाँ. Now write this. All this 4, 5, 6. GIIS, what exam do you have on Monday?
English.
Okay. And after that,
Chemistry.
on?
Wednesday.
After that?
Biology.
Okay. No, your exam, you have bio.
Yeah, I have bio, and then I think Ansh has computer science on the 25th.
So your English and then you said chemistry. Okay. Okay. Next is, this is radiation pressure. Write about radiation pressure, these three lines. This delta P, for delta P is 2 delta U by C. So delta U is the energy, what is transferred, energy of the EM waves, and P is the momentum transferred to the wall. Okay. So if your waves are absorbed on the wall, then they don't go back, right? They don't go back, and the momentum changes just one times. If they are reflected, then they go back, and the momentum changes double. So that's why there is a 2 factor in reflection. But in complete absorption, there is no 2 factor. So momentum transferred is U by C for absorption, 2U by C for reflection.
I didn't get that. Can you repeat?
Okay, which part? The 2 and the 1 part, or the U by C part?
2 lambda.
Oh, suppose there is a wall, okay, and the ball is going from left to right and hits the wall.
Yeah.
Left to right direction is positive.
Yeah.
Ball ka mass is 1 kg and the velocity is also 1 meter per second. What is the momentum of the ball?
1.
1. And suppose the ball stops there. What is the final momentum of the ball?
Ball stops at the wall.
Yeah, ball stops at the ball. What is the final momentum of the ball?
0.
0. What is the change in momentum? Change in momentum is final minus initial.
Oh, I mean 0 minus 1.
Which is minus 1, right?
Right, sir?
Yeah, the change in momentum is minus 1.
Which is minus 1, yeah.
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 Now consider the second case when the ball goes but reflects back with the same speed, same everything.
Yeah.
Now what is the initial
Okay.
momentum?
Minus 1.
Initial momentum.
Oh, it will be 1 then.
Final momentum.
0.
Hey, the final momentum. It is reflected back.
Minus 1.
Yes.
Okay.
What change in momentum?
0.
Nahin, minus 1,
1
minus 1.
oh, my 2 is that.
Minus 2.
Minus.
Final
Yeah.
is minus 1. Initial is 1. Final minus
Yeah,
initial is
Final
minus 1,
initial.
minus 1. ठीक है?
Yeah, so it's minus 2.
Minus 2. So when something is reflected back, its change in momentum is twice than when it is just absorbed.
Got it.
Okay.
Yeah.
And this is the same momentum which wall will experience. Okay.
Yes, sir.
Then write this. This is important. Energy density per unit volume. The electromagnetic energy density per unit volume is given by, which is rho. This parameter is rho. This parameter is rho. It is given by contribution due to electric field plus energy density per unit volume due to electric field plus due to magnetic field. And this ka formula half epsilon naught E square. Iska formula is B square by 2 mu naught. You should remember that the average energy density per unit volume for electric field is half epsilon E square. And the average energy density per unit volume for magnetic field is B square by 2 epsilon mu naught. Please note that epsilon naught is in the denominator electric field में, but in the magnetic field the mu naught is in the numerator. जैसा हमेशा होता है. Okay. Okay. Next thing is write this full derivation. This derivation is, you have to prove that, ऐसा prove आएगा देखो, prove that the average electric field energy and the magnetic field energy are equal. ठीक है, ये prove करने को आता है. ठीक है, तो तुम ये देखना ध्यान से, इसको देखना. स्टार्ट इसने इलेक्ट्रिक फील्ड का एनर्जी है पिंक वाली, उसने उसको रिप्लेस किया, तो पिंक वाली को तो पिंक वाली ही रखी. ठीक है, ये पिंक वाली ऊपर से नीचे तक देखो आते आते हैं. लेकिन इसको देखना ध्यान से, ग्रीन वाली को, ये ग्रीन वाली मैग्नेटिक फील्ड एनर्जी है. ठीक है, ये जब तक इसको इसने रिप्लेस किया है विद दिस फार्मूलाज, यूजिंग दिस ऑरेंज फार्मूला इसने रिप्लेस किया है. ठीक है, तो जब ये ग्रीन वाला क्या बन गया, देखो ग्रीन वाला क्या बन गया, ये बन गया ग्रीन वाला ये, और फिर ग्रीन वाला क्या बन गया, ये बन गया. देखो समझ में आया? अब देखो ध्यान से, पिंक वाली एनर्जी इलेक्ट्रिकल एनर्जी, वो तो वही रही, ये राइट. बट जो ग्रीन मैग्नेटिक फील्ड एनर्जी विच वाज seemingly different थी ना, B था उसमें, instead of E it was B and instead of epsilon naught it was mu naught. It came out to be the same. देखो इन दोनों में ये दोनों टर्म्स देखो सेम है, ये टर्म और ये टर्म सेम है ना. इसका क्या मतलब है? इसका मतलब ये है, द मीनिंग इज दिस, कि इसका जो एवरेज एनर्जी है और इनका जो एवरेज एनर्जी दोनों बराबर है, एंड यू कैन राइट देम इंटरचेंजेबली, यू कैन राइट देम, राइट. अगर R1 और R2 दोनों बराबर है तो R1 और R2 दोनों को R बोल सकते हो और दोनों को R1 भी बोल सकते हो, दोनों को R2 भी बोल सकते हो, राइट. तो यहाँ पे क्या किया है, दोनों को R1 बोल दिया है, ये R1 दोनों को बोल दिया. ठीक है, समझ में आया? तुम ऐसे भी उल्टा भी कर सकते हो, तुम दोनों को R2 दोनों को इन दोनों को b²/2 म्यू नॉट बोल सकते हो, राइट. अंडरस्टूड? नहीं आया?
Yes,
क्या आ
sir.
गया? ठीक. तो यहां से ये भी प्रूव हो जाता है कि टोटल एनर्जी जो है वो हाफ हाफ डिवाइडेड हो दोनों में, राइट. समझ में आ गया?
Yeah.
बस यही आता है एग्जाम में. टोटल एनर्जी देखो, ये हाफ इसमें फैक्टर नहीं, टोटल एनर्जी इज डबल ऑफ एनी वन ऑफ दीज, राइट. सो ये क्वेश्चन एग्जाम में आएगा, प्रूव दैट द एवरेज एनर्जी ऑफ, ऐसे भी आ सकता है, प्रूव दैट एवरेज एनर्जी ऑफ इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड इज इक्वल, ऐसा भी पूछ सकते हैं. या फिर ऐसा पूछ सकते हैं कि प्रूव दैट द एवरेज एनर्जी ऑफ इलेक्ट्रिक फील्ड इज हाफ ऑफ टोटल एनर्जी, ये भी पूछ सकते हैं, राइट. ये भी पूछ सकते हैं, प्रूव दैट एवरेज एनर्जी ऑफ मैग्नेटिक फील्ड इज हाफ ऑफ टोटल एनर्जी. अंडरस्टूड?
Yes, sir.
सब में करना यही है. Guys, done?
Yes, sir.
Okay. ये लिख लो. इसके बाद इंटेंसिटी इज एनर्जी पावर बाय एरिया, सो एनर्जी पर यूनिट टाइम पर एरिया. सो इंटेंसिटी इज इट वाज, एक मिनट, क्या था एवरेज, ये था, दिस वाज एवरेज एनर्जी पर यूनिट वॉल्यूम, राइट. सो इट वाज हाफ एप्सिलॉन ई स्क्वायर एंड देन इंटेंसिटी इज एप्सिलॉन ई स्क्वायर इनटू सी. ये लिख लो, ये राइट दिस यहाँ से लिखो, सॉरी, ये पूरा लिख लो, दिस होल थिंग. क्वेश्चन आएगा, प्रूव दैट और शो दैट द इंटेंसिटी इज गिवन बाय दिस फॉर्मूला. इट वाज rho epsilon naught c into e rms square. Done. Okay.
I'm not done.
Right, this line also. I think I forgot to tell 8. This blue line. Intensity is defines the radiation passing through unit area normal to the direction of propagation in 1 second. Done.
Yes, sir.
Yeah. Okay. Then you have applications. These you have to do on your own. Okay. You have to write your homework is writing short notes. Okay, these short notes, radio waves, and uska approximate. You have to write lambda, approximate lambda of radio waves, everything, and uska uses. Okay, used in radio. Okay, like this. Microwaves, write lambda frequency. No, we talk in terms of lambda. I don't know why. See your NCRT. Okay, see your NCRT. Usme they have given in terms of lambda or
Over here, when we said intensity is equal to C B square RMS by mu naught, right? This B RMS is the same or is the same as the C by E naught. C is equal to E naught by B naught plus B naught, right?
1 second. Can you use you over there? They have said C in I is C into B. You are talking of the formula BRMS or ERMS? B for ball or E for elephant? I can't hear you.
ERMS and ERMS, both of them. B for
Yeah.
ball and E for elephant, both of
Yeah.
yeah, are both of them like equal to the E naught and B naught we did in the beginning? Like C is equal to E naught by B naught for the formula.
No.
Okay, they're different, right?
Yeah, they are different. And you can guess what is the relation between them.
So ERMS is in a different medium, right?
No. E
So-
naught क्या था? E naught क्या था? याद करो वो करंट इलेक्ट्रिसिटी से V नॉट साइन ओमेगा टी में V नॉट क्या होता है? एम्पलीट्यूड. और VRMS कितना होता है? VRMS.
Oh, it's E naught by root 2.
Yes, it is V naught by root 2. ठीक है?
Yes, sir. But it'll be in vacuum only, right? Because we used to see is C
Everything
by.
is in अभी तक जितना बात है सब वैक्यूम है. अगर
Okay.
वैक्यूम चेक करना है वैक्यूम है कि नहीं, उसमें देखो जो एप्सिलॉन और म्यू नॉट जो लिख रहे हैं उसमें नॉट लगा है कि नहीं.
Yes, sir.
नॉट लगा तो वैक्यूम की बात हो रही है. तुम ये देख लो एनर्जी डेंसिटी अगर एवरेज निकालनी है. हाँ, इधर देखो, इधर ट्रांजिशन हुआ है. देखो ये ऊपर यहाँ पे आरएमएस नहीं है. ऊपर इसमें आरएमएस नहीं है ना.
Yes, sir.
ठीक है. लेकिन जब नीचे गए तो उसने बोला है कि बिकॉज ई एंड बी आर, देखो इसमें जब ई है ना, दिस इज एक्चुअली ई इज, ये ई पूरा ई है, इट्स फंक्शन ई नॉट साइन ओमेगा टी, उसका स्क्वायर किया. ठीक है. ये बी भी पूरा बी नॉट फंक्शन है, उसका भी स्क्वायर किया. लेकिन अगर एवरेज निकालना है तो स्क्वायर ई स्क्वायर ऑफ साइन का फंक्शन का एवरेज क्या होता है? वो एवरेज होता है 1/√2. 1/2 या 1/√2, इसीलिए उसको we replace it by ERMS. ओके,
Yes, sir.
उसमें भी करंट में भी तो यही किया था ना, I नॉट sin ओमेगा टी का एवरेज निकाला था, एवरेज ऑफ स्क्वायर निकाला था पावर निकालने के लिए, तो we replaced it by IRMS स्क्वायर. ठीक है, तो इसीलिए ERMS यहाँ पे जब एवरेज रिप्लेस दिस कैलकुलेट द एनर्जी डेंसिटी. ठीक है, तो यहाँ पे इसलिए RMS आ गया. ठीक है, ठीक है. तो फिर तुमको ये शॉर्ट नोट्स लिखने हैं, राइट शॉर्ट नोट्स, और ये बना लेना तुम. यस, दिस टेबल, मेक दिस टेबल. ओके, दिस इज योर होमवर्क. इसमें वेवलेंथ दिए, वेवलेंथ रेंज दिए हैं, देखो. यू हैव टू रिमेंबर वेवलेंथ रेंजेस. ओके, यू हैव टू रिमेंबर करना है तुमको. ठीक है, वेवलेंथ रेंजेस, और इसमें इंक्रीजिंग ऑर्डर में दिए हैं, इसलिए अच्छा है ये टेबल ही ऐसे पूरा बना लेना. ठीक है, ओके. ओ, वी आर डन. ठीक है. ऑल्सो आई विल बी अपडेटिंग द, मैं उसी में उस स्प्रेडशीट में आई विल अपडेट द होमवर्क. ओके, सो नो नीड टू आस्क. ठीक है, फाइन.
Yes, sir.
Yeah.
एंड तुम लोग दे देना. ठीक है, अब सीरियस हो जाओ थोड़ा. ठीक है, 1 महीना. ठीक है, ये सब बात बताना मुझे, एग्जाम चल रहा है, ये चल रहा है, मैं अपना रिवीजन करवा रहा हूँ. ठीक है, ओके.
Yes, sir.
I think you can invest 1.5 hours daily for physics or math. I mean, we'll do. Okay, fine. उतना तो करना ही है. ठीक है, ठीक है, जाओ.
Thank you, sir.
Thank you,
Are you
sir.
taking any class?
Thank you, sir.
Yeah, I'll be taking a class tomorrow. I'll be
What time?
सोने से पहले मैं लिख दूंगा. तुमको कुछ है? Do you have something?
No, I just wanted to ask if you're taking